back to the channel. In this lecture, I will be explaining class E chopper. A class E chopper is a dual chopper that can operate both direction of current. So it can operate both the direction of current, and both polarities of voltage. Polarities of voltage. It is also known as four quadrant chopper. Because it allows DC motor or load to operate in all four quadrants of voltage current plane. Okay, let's see the circuit diagram of class E chopper. So it consists of two chopper, two diode. Okay, now let's see the circuit diagram of class E chopper. Class E chopper consists of four chopper and four diodes. So this is the circuit diagram. So where one voltage source is connected. So this is the voltage source is positive, negative is VDC, and then here is one chopper 1. This is the next chopper. This is chopper 4, chopper 3, chopper 2. Then in anti-parallel 4 diodes are connected. So this is diode 1, D1, diode 2, diode 3, and diode 4. And the load 1 inductance and one so this is the load. This is the circuit diagram of class E chopper. This is the figure class E chopper, and this is also called a four quadrant chopper. Means it's operate in the first quadrant, second quadrant, third quadrant, and fourth quadrant. So this is called. So if we consider this is voltage and this is current, this is minus V minus I. So in this VI plane, so it's operate in the all four quadrants. So this is called a four quadrant chopper. So this class E chopper is a combination of two class type C chopper. So the combination, if we make a combination of chopper 1, chopper 2, diode 1 and diode 2. So if we make a combination of this chopper 1, then the load this chopper 2 and this diode 2 and this diode 1. So this circuit will make a type C chopper. And again the combination of chopper 3, chopper 4 and diode 3 and diode 4 is another combination to make another class C chopper. So this is called a two class C chopper. So this is combination of two class C chopper. Okay, now let's understand the working of class type C chopper. So it's basically works in four quadrant. First, second, third, and fourth. So one by one we'll understand how it will work in the first quadrant, second quadrant, third quadrant, and fourth quadrant. Okay, let's see the first quadrant operation. So this is the first quadrant operation. First quadrant operation. So when it is in the first quadrant operation, when we can achieve the first quadrant operation, if we make a circuit arrangement like this, when the chopper 1, chopper 2 is switched on, when the chopper 1 and chopper 2 is switched on and the load is okay. Let's understand the first quadrant operation of class E chopper. So in this to achieve this first quadrant operation, let's do the circuit arrangement. So this is the DC supply, this is the VDC, then chopper 1, this is inductor, that resistor, and this is the chopper 2, let's replace these two switches in the short circuit, make it short circuit. This one also, if we make it short circuit like this, short circuit. Okay, now let's see the working principle. So when this chopper 1 and chopper 2 is switch on, so in that case what will be the current flow? So first it will flow from positive VDC, positive with VDC, then chopper 1, then load, after that chopper 2, then that minus VDC. So this is the direction of the, this will, in this way that current will circulate. If we look into the main circuit, so here, so this is the conventional current flow. Now if we check the, in this first quadrant operation, so this is the direction of the current flow. So both the direction is same. So we can say this current is positive, voltage is also positive. So this is the first quadrant operation. So by doing this type of arrangement, we can achieve that first quadrant operation. So in this to achieve this first quadrant operation, chopper 1 and chopper 2 will be on. Let's understand the second quadrant operation. In the first quadrant operation, when that current will flow through the inductor, then inductor will charge. Now after second quadrant, that inductor will discharge. So when it will discharge through the diode. So this is the VDC, positive, negative, and this is the diode D1, inductor, then this is the resistor, this is the diode. Now it will discharge in this direction. So that's why, so this is the conventional direction of that current flow. Now current will flow in the opposite direction. So this current will flow from minus VDC, then diode D2, load, then D1, then plus VDC. So in this condition, so if we see, so this is V minus V, I minus I. So here current is negative, voltage is positive. So this is the second quadrant operation. So in this circuit configuration, we achieve the second quadrant operation. So second quadrant is operation achieved when diode D1 and D2 will be on. Now let's understand the third quadrant operation. So in case of a third quadrant operation, so let's see the circuit configuration. So here DC source, the DC, VDC, positive, negative. This is the chopper 4, that inductor, resistor. This is the chopper 3. So this is the circuit configuration for the third quadrant operation. So in case of the third quadrant operation, both should be negative, voltage and current, and this is the conventional direction of that current. Now if we see that current will flow in the opposite direction, according to this, that current will flow in the opposite direction. So current is negative, even here voltage is also negative. So from this operation we achieved third quadrant operation. So this will be the direction of that current flow, plus VDC, then chopper 3, load, then chopper 4, then minus VDC. And so third quadrant operation achieved when chopper 3 and chopper 4 will be on. So in this condition also it will charge that inductor. So when it will charge, it will positive, it will negative. So now again it will discharge, this inductor will discharge and it reverts its polarity. Here it will be positive and negative. Now let's see the operation of that fourth quadrant operation. Now let's see the fourth quadrant operation of class E chopper. Fourth quadrant operation. So in this operation, this inductor will discharge through the diode D3 and D4. So let's draw the circuit. So this is VDC, positive, negative. Though this is the diode D4, that inductor resistor, and this is the diode diode D3. So this is the conventional direction of that current flow, I0. Now if we see that this is in this direction, these two diodes are in the forward bias. So this will be the direction of that current flow, means, so which is the conventional direction of that current flow. So here current is positive, but we can see that voltage is negative. So we can say that in this circuit configuration, when that inductor will discharge, so at that time we achieved this fourth quadrant operation. So fourth quadrant operation achieved when D3 and D4, diode D3 and D4. So fourth quadrant operation achieved when D3 and D4 will be on. Okay, now some important observation. When the chopper works in first and fourth quadrant, when chopper works in first and third quadrant, the output voltage always less than the input voltage, always less than the input voltage. So this is a step down operation of class E chopper. Now when chopper works in second and fourth quadrant, when chopper works in second and fourth quadrant, the output voltage always greater than the input voltage. So this is a step up operation. This is a step up operation of E chopper. So this is all about class E chopper. Thank you everyone.